Hello, everybody. Hi. Okay, today I'm doing this recording for one particular questions that one of my students had a problem with. So before we look at the question itself, I just want to remind students that when we look at turning effect questions, okay, bear in mind that other than the formula for turning effect moments, force times perpendicular distance, some of the common math possible concept that I might be using you tend to be trigonometry, sine, cosine, tangent, then followed by Pythagoras theorem. Okay, because these two, I find that they are some of the common math concept that the question tend to utilize. Okay, so I will just keep this in the back of my mind whenever I deal with turning effect questions. Okay, so now let's look at the question that we are concerned. Okay, for those who have not read the question, okay, you may want to pause the video here, okay, so they can read the question first. Okay, for the rest, okay, if you are done, okay, we will look at the questions straight away. Okay, based on the question, right, it's quite a unique question whereby you have actually a beam that is like off-centered, it's like slightly slanted. Based on the question is that the question asks why is force F has no turning effect at the rods. Okay, and in this case, right, you will find that based on the question, okay, based on the particular question, okay, the rod is actually pivoted at point A. Okay, based on the question, it's pivoted at point A. So what we are looking at is actually, when we look at moments, we are only looking for two things. For the object to experience turning effect, I must firstly have the force followed by the perpendicular distance. Okay, in this question here, I have actually the force, which is F. Okay, so now what I need to make sure is, do I have the perpendicular distance? Okay, so the technique that I actually do in class is I always tell my students, okay, you actually copy the force line, the line of action of the force, which is this. So what you do is you copy the same line, same orientation, you do it at the pivot. So when I do it at the pivot, you'll find that, okay, the force between the pivot, okay, the perpendicular distance between the force and the pivot is actually the same line. Literally, what it means that is that between the force F and the pivot, my perpendicular distance is actually 0. Okay, and because of that, okay, I am actually able to conclude that the moment experienced by the beam, okay, by the rods due to F, okay, is actually 0. Okay, so for part A, once you know how to look at moment questions, the explanations, when you write the explanations to explain why there's no moments, you actually automatically includes the keywords that we need for the answer. So for A, because you know that there is 0 perpendicular distance, so remember the keywords perpendicular distance. Okay, perpendicular distance between the force and the pivot. Okay, thus I am able to conclude that the moments by F, okay, on the rods, okay, is actually 0. Okay, so if you look at the phrasing of this particular answer or these particular questions, right, the keywords that I always tell students to write to tell the marker that the students know what is moments, turning effects, is to actually write the correct keywords, the usage of the keywords, okay, which is perpendicular distance is here. And perpendicular distance, what we are interested in is the perpendicular distance between the force and the pivot. Okay, and because I have 0 perpendicular distance, my moments about the rod will be 0, or aka no turning effect. Okay, now for part B, okay, part B, okay, it involves a few steps when we look at the solving. Now, part B here is quite, give me a minute, part B here, okay, there are certain data that's given. Okay, length AB is X, so let's label this first. Length AB is X, which is this line. Okay, this is AB, which is X. Okay, then for length BC, BC is Y. So where is BC? BC will be here. Okay, so this is Y. Okay, so now we look at the question. The question asks to express, okay, in terms of theta, express R1 and R2 in terms of all the unknowns. So one of the most common way of approaching this question is to take moments about a particular point. For this question wise, right, since from part A, right, we already know that there is a pivoting point at A. So let's take moments about A. Okay. So since the rod is balanced, I will know that the anti-clockwise moment will be equal to the clockwise moment. So the first thing I do is I look at the clockwise moment first. If this is the pivot, you will find that the force I'm interested in is actually two forces. Okay. I'm actually interested in R1, force R1, okay, which has a perpendicular distance. I am also looking at the force W. Okay. In this particular case, because same as part A, R2 and force actually does not has any moment. Okay, force R2 and F actually doesn't have any moment because the perpendicular distance between them and the pivot is actually 0. So if I take pivot at A, you'll find that the two forces I'm actually interested is only R1 followed by the weight. So now you look at the perpendicular distance for each of them. Okay, so now let's look at the clockwise. Okay, clockwise I will take it as W. Is the clockwise moment is by W. So I'm interested in the perpendicular distance for W. Okay, so let's standardize. Block clockwise is blue color ink, so it's easier for everybody. So now for W, okay, the perpendicular distance for W, okay, is here. This is the line of action of the force. Same thing, to find the perpendicular distance, I copy the line, I paste it at the pivot. Okay, two parallel line, and the distance between them will be my perpendicular distance. Okay, so I will say this is dW. Okay, based on the question here, I actually can find dW if I uses trigonometry. Okay, so let's me redraw dW so that it will be clearer. Okay, now dW is here. Okay, dW is actually here. Okay, now at dW here, there is actually a right angle triangle, which is here. This is the right angle triangle. Okay, so now let's say I blow it up for you. At dW, okay, there's a right angle triangle which looks like this. Okay, this is angle theta. Okay, and this is your length x. Length x is actually AB. dW is actually what I call the opposite side of theta. So if you look at simple trigonometry, you'll find that dW can actually be expressed as x sine theta. Okay, so the perpendicular distance dW can actually be expressed as d sine theta times x, which means for clockwise moment for weight, it will be force times distance dW, and dW can actually be rewritten as, or can be expressed as x sine theta. Okay, so now we have the clockwise moment settled. Now we look at the anti-clockwise moment. Okay, so the anti-clockwise moment is, we use a red color ink so it's easier to see for everybody. Now, anti-clockwise moment here is now I have by R1. Okay, now same thing to find the anti-clockwise moment. Okay, what I do is I use the same method here, copy the line of action of force, I copy it to the pivot, which is here, and I want the distance between them, okay, which is here. The distance between them, dr1, is actually here, which happens to be x and y. Okay, so effectively, if you look at the anti-clockwise moment, okay, it's actually controlled by R1 plus the perpendicular distance dr1. And R1 is here, and dr1 can actually be expressed in terms of x and y just by simple x plus y. Okay, because xy is actually angle AB and length AB and length BC. So now you will have the equations form up because of your principle of moments, clockwise equal anti-clockwise, because the rod is balanced. So now let's simplify. Okay, the question said I want to express R1. So express R1 means I will actually have to shift xy over. So the final equation will look something like this. Okay. Divide by x plus y. Okay, so this is R1 in terms of W, theta, and x and y. Okay, so this is the first step to getting R1. Now, if you look at R1, right? If you look at the approach for R1, I actually cannot get R2. There's no way I can get R2 in the equation if I continue to take pivot at A. Okay, so if I take pivot at A, there's no way I can get R2 inside my equation because R2 is at the pivot which has no moment. So what do I do now is instead of taking moment at A, I shall actually take moments at at C, sorry. So let's take moment at C. Okay, so now let's take moment at C. So I take pivot at C. Okay, so if I take pivot at C, same thing will happen. You'll find that R1 and F actually has no moment. Okay, because it's the perpendicular distance between them and the pivot is actually 0. So now, same thing as before, I will look at clockwise moment equal to anti-clockwise moment. Okay, the only difference now is that the clockwise moment now is caused by R2. Okay, so the clockwise moment is caused by R2. Okay, so here the clockwise moment is about the pivot at C, the pivot at C. So same thing as before, what do I do now is I want to find the moments by R2, so I will need the perpendicular distance. Okay, so if you look at the parallel line, I will draw a parallel line between R2. So the distance between the two parallel lines will be your perpendicular distance, which is here. Okay, so this will be your dr2. Okay, so moments by R2 will be force, which is R2 times perpendicular distance, dr2. So now the next step you need to do is actually to express dr2, perpendicular distance of R2, in terms of x and y and theta. Okay, so now if you still can't see it, there's actually one right angle triangle here. Okay, so the right angle triangle, let me draw it here. It will be this way. This is A, this is C. This will be dr2. And this is theta. Okay, and here, students, you have to be careful. The AC is actually x plus y. Okay, so all right, 10 minutes time. So I got 10 minutes for the video. Okay, so now let's quickly finish up. Okay, before I'm locked out in school. Okay, now for dr2, the theta is here. Okay, the hypotenuse is x plus y. So straight away, I will actually can actually resolve dr2 to be x plus y cosine theta using cosine theta or what we call trigonometry. Okay, so which means I can actually resolve R2 here. I can resolve dr2 to be x plus y cos theta. Okay, so now I have the clockwise moment. So what I do now is I will get the anti-clockwise moment. Okay, now anti-clockwise moment now is actually caused by the weights, okay, which is here. Okay, same thing as before, the perpendicular distance between the weight is actually here. Okay, to make clearer, it's actually somewhere here. This is the perpendicular distance, dw. Okay, same as before, there is actually a right angle triangle here. There is actually a right angle triangle here. There's actually a right angle triangle here. So same thing, let me redraw it again. Okay, so the right angle triangle I'm looking at is actually here. BC. Okay, so this is dw. BC, based on the question, this is y. Okay, and same thing, basic trigonometry. Okay, parallel lines. If this is theta, this will be theta. Okay, corresponding angle. So this angle here will be theta. Okay, so take note of the theta. Okay, and once you know that is theta, you will know that dw is actually the sides opposite angle theta, which can be written as y sine theta. Okay, so for your anti-clockwise moment is caused by the weight, followed by dw, and dw can actually be resolved into y sine theta. Okay, so with that, okay, same thing, simplify the equation. I want R2, sorry. So I will shift xy cosine theta to the other side. It will be w y sine theta divided by x plus y cosine theta. Okay, and after that, do a simple resolving. Okay, why? Because sine theta, cosine theta, I can actually resolve it to be tangent theta. So with wy tangent theta over x plus y. This is R2. Okay, question solved. Okay, so if you look at the questions, the solving, okay, it's actually quite mathematical. Okay, so it involves a bit of trigonometry and trigonometry. Yeah, maybe in this case we have not used Pythagoras. Okay, so if you are not sure of any part that you need to rewind, to relook, okay, feel free to pause the video and actually go and relook at a certain part. Okay, other than that, okay, I need to rush off now. The school is closing. Okay, but if you have any, you still have any problem, okay, just let me know. Drop me an email or drop me a comment in the video below so that I can get back to you. Okay, if not, this is where I stop. Okay, I hope, okay, yeah, I have solved like all your problem for this question. Okay, if not, see you in class. Bye bye.